to invite Dr. Datta to deliver his talk. Please, Datta, please. यार क्या जा रहे हो? कहाँ जा रही हो? हाँ? अच्छा, प्रेजेंटेशन के लिए जा रहे हैं क्या?
सर बुलाए।
सुशील सर बुलाए हैं?
Organizer for inviting me. I am Dr. Jaunpur from TDPG College, and today I am going to present one of my work, that is the press classifier. So the conference is on computer science machine learning. So we should know what is machine learning. So machine learning is something subset of AI that focuses on measurement of algorithm models in order for computers to learn from data. And learning process allows inputs performance on a task over time without explicitly programmed. Means no programmer is doing programming for that. Explicitly means it is not putting the knowledge of human being in the machine. It is learning from data. It is not learning from human being. That is the main thing. Now, there are three types of machine learning. One is supervised learning, another is unsupervised learning, and another is reinforcement learning. So, supervised learning means when we are giving the data, we are giving the input as well as output. Means we know the class level. And we know the input. In case of unsupervised data, we are giving the input only. We are not giving the output. Means no supervisor was present over there. And in case of reinforcement learning, the learning took place by means of some reward and penalty. Now, here I will discuss about one type of supervised learning, that is classification. Classification or classifier building is a supervised learning process. Here we are doing it in two steps. One is step 1 and another is step 2. In step 1 we are constructing the model. We are giving the training data where input is given and output is given, and the model is learned by the machine. Now, so supervisor or class levels are there, okay, and model is learning that how to map the input to the output. We are learning the mapping function at this stage, and after that the learning is over. In step 2, we are judging what is the quality of that learn. Means what is the quality of the classifier? Main quality of the classifier is the accuracy of the classifier. We are giving unknown data set to the classifier, and then we are measuring the accuracy of the classifier. That is step 2. So see here, we are giving the training data. Okay, some training data are here. See, these are the input and tenured or not. These are class level. Yes or no? We are giving that to the classifier. Suppose classifier is learning this model. Okay, and suppose it learns this thing. This branch processor or year of experience is greater than 4, then tenure equal to yes. Learn this. Now after that, we are giving the testing data, and we are checking whether the learned model able to classify it properly or not. Tenure yes or no. And we are measuring the accuracy. How many data is classified properly, or there may be different types of computing. One type of computing is dealing with preciseness, that was known as conventional computing, that is hard computing, and nowadays we are talking about soft computing. We are dealing with impreciseness and all this thing. So following the nomenclature of hard computing, there may be different types of classifier, tree-based classifier, association tree-based classifier, AVL methods are there. Then following soft computing, there are various types of classifiers, so neural network-based classifier. Now here I am going to discuss one type of classifier, that is genetic algorithm-based classifier. Now what is genetic algorithm? Genetic algorithm are adaptive heuristic search technique inspired by the principle of natural selection and genetics. They are widely used in optimization and machine learning problem where search space is large and complex. In the field of classification, genetic algorithm-based classifier apply evolutionary strategies to automatically discover high-quality classification routes from data. Okay, so see here what we are doing. We are trying to find out a classifier where accuracy is the most. So basically the problem of building classifier is a optimization problem. We want to maximize accuracy. So it's a optimization problem. So we are using a global optimizer, that is genetic algorithm, to build the classifier. Now there may be various types of genetic algorithm. One is single objective genetic algorithm, another is multi-objective genetic algorithm. There may be many objective genetic algorithm, but I am not going to that. I will stick to single objective genetic algorithm and multi-objective genetic algorithm. So in case of single objective genetic algorithm, suppose we want to build a classifier which will maximize the accuracy, that's all. So in that case we can use single objective genetic algorithm. But our classifier building process is not so simple. Okay, so we have to maximize accuracy, we have to make the classifier as general as possible, we have to make it interpretable, so a lot of properties are there. So for that reason, we are going for multi-objective optimization problem, and we are going to use a genetic algorithm, that is multi-objective genetic algorithm. That is MOGA. In short, it is MOGA, multi-objective genetic algorithm. Now see, to understand the multi-objective genetic algorithm, we can take this example. Okay, suppose we want to buy a car. Okay, now how we are buying a car? What are the objectives? When we are buying a car, one objective may be the minimization of the cost of the car. That may be one objective. Second objective may be maximization of comfort. Okay, now there may be various types of car. Okay, in one car, suppose we are going for say minimization of cost, then Tata Nano may be the best choice. Okay, suppose we are going for maximization of comfort, then Mercedes-Benz may be the best choice. But in between there may be various solutions, various cars are there. So lot of solutions exist, and all these solutions are basically known as Pareto optimal solution. There is a line, there is a car on which various solutions, various cars exist in the market, and we can go for any type of solution. Similarly here, when we are going to find out different types of classifier and when we are going to use multi-objective GA, we can get lot of classifier. Not a single solution, we may get lot of classifier solution. Among those classification solution or classifier we have to pick up one. Now, so this is the definition of multi-objective optimization. Means we have to maximize or minimize lot of objectives with some constants are there. Some functions are there, some conditions are there. Some variables have some lower values, some higher values. Now, from here I am entering into my work, what I have done. Okay, so my work was published in, this work was published in 2020 in Expert System with Applications, and during that time the impact factor of this journal was 8.5. Okay, and according to Google H Index, that was the #1 journal in the field of artificial intelligence during that time. Okay, so this was my work. Okay, part multi-objective genetic algorithm. Now, among these, I think I have already explained what is multi-objective genetic algorithm, and I have already explained what is classifier. Okay, now life is strong, I will explain. Now, objectives of the classifier. First thing is the classifier must be accurate and interpretable. Accuracy, classifier must be accurate. First thing, and second thing is interpretable. Means classifier is doing the classification. Means if this is the input, then the tenured yes or tenured no. Okay. So accuracy means how accurately it is judging the class level. Tenured yes, tenured no. That is accuracy. Second thing is that classifier is doing that, but how human being is understanding it. Okay. How it is taking its decision. So that is interpretable. Now, accuracy is how you can measure accuracy. Number of correct prediction divided by total number of prediction multiplied by 100 is in percentage. Okay. We are doing this for testing data. Now, interpretability, how machine can understand this. So, how you can increase interpretability? We can make the classifier general and simple. By this, we can make the classifier interpretable. So, we have seen that with the increase of accuracy, normally interpretability decreases. So, these two are contradicting each other. If we are trying to increase the accuracy, interpretability is decreasing. So, it's a quantity-objective optimization problem. So, in Wikimoka-based classifier, we are trying to increase both accuracy and interpretability. Okay. So, it is a rule-based classifier, means we are denoting this classifier by means of simple if-then rules. If this, then tenure. If this, then not tenure. So, it is understandable by human being. And rules are extracted by MOVA, and as it is a global optimizer, so it is globally optimal and in pseudo classification accuracy. Now, what I have told, it is a biphased genetic algorithm, means there are two phases, phase 1 and phase 2. Okay. And both phase we are using MOGA, multi-objective genetic algorithm. And in both phase, as we are using multi-objective genetic algorithm, more than one objectives are there that we are optimizing. Okay, so in phase 1 there are some objectives, in phase 2 there are some objectives that we are optimizing. Now, I am talking about phase 1. So in phase 1, we are extracting class specific rule. Means if these are the case, then tenure. Then in another rule, we can say that if these are the case, then not tenure. Okay. So class specific rules are there, some class specific rules are there. What are the objectives? We are trying to make each class specific rule as accurate as possible. So confidence. Confidence means accuracy of that particular rule. Then coverage, that rules should be as general as possible. So coverage. Next one, to make it simple, we are taking number of valid features within that rule. So if in the condition, suppose if this is the case, then this is the case, then this is the case, then it is tenure. If this is the rule. Rather than if you can say, if this is the case, then tenure. Then the second rule will be more simpler and understandable by human being. More understandable by human being. So we are trying to make rules as simple as possible. So the formula of confidence is support of antecedent and consequence. If you take all conditions, means input and output, all conditions together, input are known as antecedent and consequence are known as class level. So we are counting the number of records in the training data which are supporting this, support antecedent and consequence, divided by number of records which is supporting this antecedent, means fulfilling the antecedent condition. Coverage, we are getting support of antecedent plus consequence divided by support of consequence, that is the, we are counting the class level. Then number of valid features I have already explained. So this is for phase 1. So this is the flowchart of phase 1. I am not going to the details of that flowchart because that will take long time. Okay. So next, what we are doing with this rule, we are getting class specific rule for every class. Suppose if these are the case, then male. If these are the case, then female. Or if these are the case, then disease is there. Or these are the case, then disease is not there. So for each class, we are getting class specific rules. Now what we have to do, in order to classify the whole data set, we have to have a classifier which have both type of thing. Means if these are the case, then male. If these are the case, then female. So we require for a classifier we require both type of rules, class specific rules. So by combining class specific rules, we are getting complete rules. See, in the complete rules, lot of class specific rules are there. If else, ladder is there. So we are getting complete rules, and we are also trying to optimize the objective of complete rules. So what are the objectives? We are increasing the total accuracy of the classifier, that is total confidence. We are trying to make it as general as possible, so total coverage, and number of class specific rule within that complete rule that we are trying to minimize. Means if we have less number of rules, then it will make more interpretable to the human being. Okay, so we can do it. So these are three objectives. Now, one of the unique thing for biphased multi-objective GA is that in both phases we are using multi-objective GA. We are getting CR, means phase 2 from phase 1. So whatever the output of phase 1, we are using that output as an input of phase 2. Now, in phase 2, we are getting several CR that is lying in the Pareto optimal form. Now, from those CR, we may get lot of CSR, means class specific rule. If we take one CR, we may get lot of class specific rule. Those class specific rule will be the input for the next run of phase 1. So it's a cycling. So phase 1, phase 2, phase 1, phase 2, in this way we are continuing, and ultimately we are stopping after 20 iterations. So after 20 iterations, we are getting a lot of classifier that is lying in the Pareto optimal form, and among these we are choosing one classifier for testing. Okay. So see, this is the flowchart of phase 2. Then this is the complete flowchart, means we are combining phase 1, phase 2, phase 1, phase 2 in this way. Ultimately we are getting some CR lying in the Pareto optimal form. Okay. Now see, this is the diagram. So initially we are giving the data set to the phase 1. Data set means training data to the phase 1. Phase 1 is producing CR of each class Pareto optimal form. In the Pareto optimal form, each class we are getting some Pareto optimal form. So we are getting a lot of rules that is lying on the Pareto optimal form for each class. Then from those we are combining them randomly. Then we are getting CR. Those CR which are lying in the Pareto optimal form, we are taking them, and then those CR will, from those CR we will extract CSR, and that will be the input of phase 1. So this process will continue, and after some time, after 20 iterations, we are getting some CR. That is some classifier. Okay. Among those classifiers, we have to pick one for means accuracy measurement and generalizability measurement and all this. Okay. So what do we do after that? We got a lot of classifiers. Among those classifiers, we have taken one classifier for accuracy testing. Okay. Now, for that, what we have to do? We have to prove that our classifier is better than other classifiers. Because you know that there are a lot of classifiers. Okay. So what we did, we have taken 21 data sets from UCI machine learning repository, and we have compared our classifier. Last one is classifier with existing classifier. So we have compared performance of our classifier with the help of 21 data sets, and we have compared our classifier with other 7 genetic algorithm based classifiers, and see the accuracy. Our accuracy is 79%. Okay, which is comparable or better than other genetic algorithm based classifier. Then what we did, we have also compared performance of our classifier with some non-genetic algorithm based classifier. Okay, C4.5 is a decision tree. Then MNPDP means neural network based classifier. We have done that. Okay, and again it is showing that it is better. And then we have done some statistical tests. Statistical tests also shows that our classifier is at least comparable or better than existing classifier. Okay, so with this I am concluding my work. Okay, now what I after this work, what I have done. Okay. So next thing is charging the time complexity of the BP motor. That is one of the issues that I have not yet done. Okay. Now it is taking, if we process it in say normal computer or in a serial way, it is taking huge amount of time. So what I did a parallel version of BP motor that I have already implemented. Then this is BP motor biphased. Then I have developed another algorithm that is triphased motor. 3 phases of it. Phase 1, phase 2, phase 3. So phase 1, output of phase 1 is the input of phase 2. Output of phase 2 is the input of phase 3, and phase 3 output is input of phase 1 again. That we have done. And I have also implemented one classifier, that is CNN based classifier, means convolutional neural network based classifier. Although this classifier is not interpretable, means how the classifier is working, that is not clear to the human being, but the performance of this classifier is better than BP. Accuracy is much better. Okay. So with this work, I am concluding my lecture. Again, I want to thanks for your patience hearing. Okay. Thank you. If you have any questions.
Is there any question? Do you want to ask any question? I have one.
Yes.
Once again.
Sir, you know Kalyan Dev?
Yeah,
Dev.
yeah.
He has got maximum
Yes.
citizens. Isn't
Yes,
it?
yes, yes.
You might have followed him also.
Yes.
That's
I know him personally. He
Yes,
knows me
that's why
personally.
yes.
Thank you.
Next speaker is J. Rawal from Mumbai.